GATE 2015 Civil Engineering Set 1 Question 43. Two reservoirs are connected through a 930 meter long 0.3 meter diameter pipe which has a gate wall. The pipe entrance is sharp of loss coefficient 0.5 and the valve is half open with a loss coefficient of 5.5. The head difference between the reservoirs is 20 meter. Assume the friction factor of the pipe as 0.03 and G equals 10 meter per second square. The discharge in the pipe accounting for all minor and major losses needs to be found in meter cube per second. The relevant NPTEL reference has been listed. So if we are given one reservoir and another reservoir at a different height and we need to conduct a flow from reservoir 1 to reservoir 2. So there will be some losses that will be happening in this pipe. So first loss will be a major loss, that is due to the friction coefficient in the pipe. This is calculated from Darcy-Weisbach equation. So we will have a certain elevation in this reservoir and certain elevation in this reservoir. So the separation of the top levels is called as delta H, which is the head difference between the reservoirs. This head difference will cause the flow. So delta H will get distributed into kinetic head and the losses. So kinetic head would be equal to V square by 2G, that will be the speed of the flowing water in the pipe, plus there will be major losses plus there will be some minor losses. So major losses are given by Darcy-Weisbach equation, which is FLV square by 2GD. Here V is the velocity of water in the pipe, G is the acceleration due to gravity, D is the diameter and L is the length of the pipe and F is friction coefficient. Then there will be some minor losses which are given by kV square by 2G and summation we can put I equals 1 to N depending upon what kind of losses we are considering. So there will be some entry loss, sometimes there will be an exit loss, there can be a loss due to a pipe valve or a bend in the pipe. So due to these things there will be some loss which will be controlled by the coefficient K. So all these factors such as the kinetic head, major loss and minor loss will add up and form the head difference between the reservoirs. This concept will be used to solve this problem. So in this case the head difference is given as 20 meter, length of the pipe has been mentioned as 930 meters, diameter is mentioned as 0.3 meters, friction coefficient of the pipe is given as 0.03, the value of G is mentioned as 10 meter per second square. The constant for valve is given as 5.5. The constant for the entrance is given as 0.5. So as we saw, delta H will be equal to the kinetic head plus major losses plus the summation of the minor losses. So here delta H is 20. V we do not know, so we need to find the V, divided by G is 10. F is given as 0.03, L is 930, V we do not know, divided by 2 times of 10, diameter is given as 0.3. Now we need to consider the minor losses. So here there are two minor losses. First is due to valve and second is at the entrance of the pipe. So this would become 5.5 V square divided by 2G, that would be 20, and another will be due to the entrance, that is 0.5 square divided by 20. So taking 20 common from all the fractions and sending it to the other side, it would become 400 equals V square can be taken common. This would become 1 plus 0.5 plus 93. Using this we would get the value of V square as 400 over 100, that is 4. From this V is obtained as 2 meter per second. Now we need to find the discharge in the pipe. So discharge will be equal to the area into velocity. So area would be pi d square by 4 into velocity. So pi is 3.14, d is 0.3 square by 4 into velocity, that is 2. This would give the value as 0.1414 meter cubes per second as the discharge in the pipe. So the discharge in the pipe accounting for all minor and major losses is given by 0.1414 meter cube per second. The relevant NPTEL reference has been listed.